Okay, in this video I'll be talking about bases other than E. So this is just dealing with still exponential functions, but instead of having like the natural log, it's going to have like a number as the base and then raised to some variable exponent. Just some general info on this section is just a to the x means e raised to like the natural log of a times x, and then this is just change of base formula with log rules. And this is what I'll mostly be focusing on for this section is the derivative rules, as well as this one integration rule for bases besides e. So in this case, a is going to represent a constant, so like just a number, so like 5 or 6, 7. The first rule is that the derivative of a to the x equals the natural log of a times a to the x. Second rule, derivative of a to the u is equal to the natural log of a times a to the u times u prime, so the derivative of that exponent factor. Number 3, the derivative of the log base a of x is equal to 1 over the natural log of a times x. And number 4, the derivative of log base a of u is equal to 1 over the natural log of a times u prime. The one integration rule that's associated with this section is that the integral of a to the x dx is equal to 1 over the natural log of a times a to the x plus c. So here I have just a couple examples. This first one, we're going to differentiate, and here we've got two factors, so we're going to have to use the product rule. So our y prime is going to be equal to t squared times the derivative of 2 to the t plus 2 to the t times the derivative of t squared. So here we have t squared. Now the derivative of 2 raised to the t. In this case, the 2 would be our a, and the t would represent our x. So our derivative is going to be the natural log of a, so the natural log of 2, times a to the x, so times 2 to the t, plus 2 to the t, and the derivative of t squared is just 2t. So now if you wanted to, you could do some simplification, and you could factor out a 2t times t, and then be left with that is your answer. But if this is a free response, then this would be correct right here. So you wouldn't, if this was a free response question, you would just, this answer right here would be acceptable. Now for this one, we're going to be using rule number 4 for our differentiation rules. And so we're going to have y prime equals, and it's going to be 1 over the natural log of a. A in this case is that log base a, so it's going to be the natural log of 6 times u. U in this case is x to the third, and then times u prime. The derivative of u is just 3x squared. And there would be our answer. Now another concept in this section is compounding interest. So this is like when you make a deposit at a bank and they give you a certain percentage of money for keeping your money inside your account so many times per year. Sometimes they'll do it n times per year, and sometimes they'll do it continuously. And so I'm just going to go into an example. These are just the two formulas. For R is the rate, N is the number of compoundings, T is the time in years, P is initial deposit, and A is total amount. So for this one, a deposit of $1,000 is made into a fund with an annual interest rate of 5%. So R equals 0.05, P equals 1,000. We want to find out what T is for the investment to double if the interest is compounded continuously. Whoa. We start out with this, and we want to find out what the time in years necessary for the investment to double. So for 1,000 to double, that would be 2,000, and that would now be our total amount, equals 1,000 e to the 0.05 t. Divide by 1,000, and you get that. And then if you take the natural log of both sides, you can get rid of this e. And you're just left with 0.05 t. Divide both sides by 0.05. And if you do that on a calculator, you get approximately 13.86 years. So there's 5.5, mostly just plugging stuff into formulas and just basic review of derivative rules. Hopefully that made sense.